welcome to today's class Ace Math with Joy. Alright, now have you ever seen a question like this? Probably in past question, maybe you are getting ready for JAMB, mathematics JAMB, or further mathematics, or even mathematics, WAEC, NECO, or whatever exam you're getting ready for, and then you come across a question like this: the limit of x squared minus 4 over x minus 2 as x tends to 2. Have you ever seen a question like that and then you wondered what exactly you were expected to do? So today we're going to be looking at limits and functions. So at the end of today's class, you will understand what limits is, what function is, and then you should be able to evaluate limits. All right, now the next question is, what is function? So we're starting with functions. For us to understand limits, we need to know what functions are. So in the world of calculus, you need to know what is function, what is limit before you come to differentiation and integration. If you do not understand this topic and you are trying to understand especially first principle of differentiation, you will find it a little bit challenging. All right, now function is a rule that assigns exactly one output to each input, right? You said function is a rule that assigns exactly one output to each input. So now if that is what function is, let's think about function as a machine, right? Okay, now a machine, you put something, let's say in a bread making whatever, you mix up something and then you give it to the oven produces bread and gives it to you. So that flour mixture is your input, and then the output, which is the cake you get in return, is the what? Is the output. All right. So now if we have f of x to be equal to 2x plus 3, now if we put x to be 1, that's the input, what are we going to get in return? We will have f of 1 to be equal to 2 times 1 plus 3. So that means f of 1 is equal to 5. So for any input 1, we'll get an input 5. Okay, so now what if we put an input, let's say 4, into this same function? We will have, which is 2 times 4, 8 plus 3, that is 11. Okay, so now when you put another input 4, putting an input 5 gave us an output 5. Input 1 gave us an output 5. Input 4 gave us an output 11. All right. So now one input cannot have two different outputs. Except it is not function. But if it is function, it is one input to one output. You can't put 2 and expect to get 5 and 11. Or you are putting 4 and expecting to get 1 and 6 at the same time. One input, one output. So now what is the notation for function? The notation for function, just like you rightly saw in that example, is f of x. Please don't be scared. Now, this f of x simply means that the value of the function simply means what is the value of the function when the input is x, right? Okay, so what's the value of the function? This f stands for function. What's the value of the function when the input is x? As you can see in the example cited, when x was 1, we imputed 1 into the function, right? And we got a value. Beautiful. So now the notation for function is what? F of x. Now, in some questions, you can have, when you have more than one function, in order to differentiate, we can't have f of x and f of x when they mean different things. Look at what I mean. You can't have, for instance, f of x to be equal to, that's for those who have done mapping and function, you can't have f of x to be this, and then you have f of x again to be this. Remember I said earlier it is one input to one output. So having this will cause confusion. So in that case, for one question or in one case, when you have two different functions, that is when you can use a letter G, all right, so as to differentiate one function from the other. So you can have f of x to be equal to 3x plus 4, and then you have g of x to be equal to 4x plus 3. g of x to be equal to 4x plus 3. Okay, so if you have two functions in a question, you can use a different letter other than f. That's why we use g. Okay, now having known that, let's look at an example of function. So if f of x is equal to x squared plus 2x minus 3, if we have an input, if x is, find f of 2. So now to find f of 2, what it simply means is if f of x is this, then f of 2 will be what? So in place of x, put 2. So f of 2 is simply going to be 2 squared plus 2 times 2 minus 3. So we have 4 plus 4 minus 3, and that will give us 5. So f of 2 is equal to 5. So basically this is what function is, as simple as ABC. Now, so generally for any f of a, we have a squared plus 2a minus 3. So now, having understood what function is, because if you don't know what function is, you will not understand where limit is coming from. Now that we understand function, let's talk about limit. Supposing f of x is equal to x plus 3. Now, what happens to f of x as x gets closer and closer to 2? That's a question. If the function f of x is equal to x plus 3, what happens to f of x? Remember that f of x is the output where x is the input, right? So now, what do you think will happen to that output when the input is getting closer and closer to 2? Now, let me show you what I mean. I have an input x and I have an output f of x. So now I ask a question, what happens to the output f of x as x is getting closer and closer and closer to what? To 2. Okay, so now if you replace this x with 1.9 and then add 1.9 to 3, what do you think you'll have? You simply have 4.9, right? Remember that this your f of x is x plus 3, so that you understand where I am getting my f of x from. Now, if x is 1.99, replace x with 1.99, you have 4.99. Replacing with 1.999, you also have 4.999. But then if x is 2, what do you have? You have 5. Okay, so now what if x is, let's say, 2.001, for instance, you also have 5.001. All right, so as x approaches 2, the function f of x approaches 5. Therefore, we say that limit of f of x as x tends to 2 is equal to what? Is equal to 5. Now, what does it mean? It means that the value that f of x approaches as x gets closer to 2 is what? Is 5. So limit is about approaching. That is why we use this symbol. It doesn't mean that x is equal to 2. No. All right. That's why we didn't say limit of f of x as x is equal to 2. We say limit of f of x as x tends to or as x approaches. All right, very good, so that you understand. All right, now approaching 3. Now that x is 3, so what do we simply do? We just say let x be what? 3. That's direct substitution. So substituting x to be equal to 3, we have this, which is equal to 11. Now what it means is that as x is approaching 3, f of x, the limit is also what? Is also approaching 11. The limit is also approaching 11. Okay, So now what if its limit as x squared, limit of x squared plus 3x minus 1 as x tends to what? 2. Now I want you to look at these two questions. Addition, adding the limits will simply add the results. Are you getting what I'm saying? So it applies to addition, it applies to subtraction, it applies to multiplication, it applies also to division, given that m is not 0. Because when m is 0, then the limits will do what? Will be undefined. Now, these laws are simply the reason why direct substitution will work or works for many polynomial functions. Now, we've looked at this substitution. What are the methods of evaluating limits so that you don't think that substitution is the only method? What are the methods? So, number one, we have direct substitution, which we have looked at when we're looking at example of limits. We have the direct substitution, and I think we've seen that example severally. So the second one, we have factorization. And I think we've also seen that. So if you have limits of x squared minus 9 over x minus 3 and x tends to 3, what happens? Factorization method is saying you should factorize the one that is quadratic. So that will be x minus 3. This is difference of two squares, x plus 3. And I've said earlier, it mustn't be difference of two squares. That's not the only quadratic expression that can be factorized, right? Okay, so if you have x minus 3, x plus 3 all over x minus 3. So this will cancel out, and then we have limits as x tends to 3 of x plus 3. So we now substitute, and then that will be 3 plus 3, which is 6, right? Okay, so that is factorization. Now we're going to look at rationalization. That's the third one, rationalization. What happens when you have a function or a limit and sort is involved? Rationalization. So now let's look at this example. If I have limits as x tends to 4 of the root of x minus 2 over x minus 4. So now before we talk about rationalization, let's just look at direct substitution and see what happens, right? So now if since x is tending to 4, so I'm going to substitute x to be 4, and then that will be root 4, which is 2. So we have 2 minus 2 over 4 minus 4, and that will give us 0 over 0. Do you see that now? Which is undefined. So which makes this limit undefined. But is that true? Let's find out. So now rationalizing, since I have solved in the numerator, let me rationalize. Rationalizing the numerator, the conjugate of that numerator, of that sort there, is going to be root. So we'll have root x minus 2 over x minus 4 times plus 2. That's the conjugate of that numerator. Okay, so we cannot multiply only the numerator and leave the denominator. So whatever we do in the numerator, we do it for the denominator. They are in this together. Okay, so when we multiply this, root x times root x will end up giving us x. Minus times plus is minus. 2 times 2, 4. You see why I didn't bother multiplying root 2 times 2 and then minus 2 times root x? Because it will give me 0, right? I will end up having 2 root x minus 2 root x. So it's like difference of 2 squares. You get? Okay. So for the denominator, what am I going to have? Let me not stress my head. Let me just leave it as x minus 4 and then root x plus 4. Because trying to multiply out might make the whole work cumbersome. So now I'm seeing two things that are the same, right? Okay, so they will cancel out at this point. So if they cancel out, I have 1 over root x plus 2. So at this point, if I substitute my value of x, what am I going to have? That's root 4 plus 2. And that will give me 1 over 4. Okay, so that means the limit of that function as x tends to 4 is 1 over 4. Okay, now let's look at limits at infinity. Limit at infinity. Now, what happens when x is tending to infinity? Have you ever thought of, or is it just when you see a question and you're seeing x tends to infinity and you're like, so what am I supposed to do? Have you ever thought of that? You know, the examples we've given, x is approaching 2, x is approaching 4. So you can easily say, okay, since x is approaching 2, let's call x 2, right? Since x is approaching 4, let's call x 4. Now, if x is approaching infinity, can you count infinity? It means that x will become so large that instead of approaching a particular finite number, it will be approaching 0. Do you get it? So if x begins to approach infinity, that means the limit. Okay, let me give you an instance. If we say the limit as x approaches infinity of the function 1 over x. Okay, so what do you think we're going to be having as our limit? We have 1 over 10, so large, so large. We have 1 over 100. The number is not ending. It's not end as x is approaching what? Infinity. I hope you know that. 1,000. From 1,000 we enter tens of thousands. From tens of thousands we enter, oh my God. And it will keep moving, oh, because the x is approaching infinity, so it's not ending. Are you getting it now? So now imagine 1 over 10 will give you 0.1, abi? 1 over 100, what will it give you? 0.0. 1 over 1,000, 0.00. So now imagine if the denominator keeps increasing, because that's where x is, right? Now, if it keeps increasing and increasing and increasing, what do you think the limit will be getting to? 0, right? So limit of as x tends to x of 1 over x is always approaching what? 0. So that is why when you see questions that has to do with limits as the x tends to infinity of a polynomial, what do? You try to divide through by x. So when you divide through by x, you factor out that 1 over x, and then you go ahead with your calculation. I hope you understand what I just explained. So now, what is the connection? Let me ask this question that somebody might be asking. What is the connection between limits and functions? So why are we bringing them together? What's the connection between both of them? Now, limit helps us to understand the behavior of a function. Are you seeing it? It is limit that helps us. Function, we've known that, okay, if f of x is equal to this, it means that what is the value of this and that and that. But it is limit that helps us to understand the behavior of a function. If x takes this value, what happens to the function? What will be the limit the function can take or can get to? So it is limit that helps us to do what? To understand the behavior of function. Now we say the function tells us what output is. All right. So if I put an input, a function tells me this is what my output will be. So now if f of x is equal to x plus 2. Function tells me that f of 2 is equal to 4. So what does limit tell us about this function? Now limit says limit of that function f of x as x tends to 2. Remember we said when x is 2, that was why we have 4. Okay, so x tends to 2. What would that be? That's 2 plus 2, which is also 4. So now limit is telling us that this function x plus 2, that the maximum it can get to is what? Is 4. So with limit we understand the behavior of function. Is function a good girl or a bad boy? Right? Okay. So now getting 2 as my function and getting 4 as my limit. 4 as my function, 4 as my limit. I want you to note that it is not always true. Function and limit must not be the same. So that when you have a function and then you say let x be this, and then finding the limit, you're not getting the same. Just know that it must not be the same. A function might even be undefined at a point and still have a limit. Yes, a function might be undefined, but it will still have what? It will still have a limit. So now finally, a function f of x, when is it said to be continuous? And that will lead us to our next lesson, which is differentiation by first principle. Now a function f of x is said to be continuous at x equals a, if, take note of the following. Okay, now a function f of x finally is said to be continuous at x equals a if these three criteria are met. The first one, if the function a of a what exists. Remember that x is equal to a, right? So if it exists, that's the first thing. Then limit of f of x as x tends to a, does it exist or is it undefined? Good. Now if that happens, the next question is the limit of the function of x as x tends to a the same with the function of a. Now if that happens, then we know that the function is continuous. So now this continuity will lead us to our next topic, which is what? Differentiation by first principle. Now I hope you've learned that limits are the foundation of continuity, differentiation and much of calculus. Now I want to believe that this video has helped you to at least to get a basis or to have a grip of what calculus is all about, especially on the foundation level. So please, if you are helped by this video, please join us in our next class as we look at the differentiation by first principle. Do well to subscribe so as to get notification when the video drops. See you in the next class.